All right, hello everyone. I'm going to get started in just a second. So this week we're doing Python jails. First, a couple announcements. Yes, so we have a social with WeSees. So it'll be Monday. You guys should come out. We'll do origami. There'll be a bunch of snacks. It'll be a good time. Also, Seesaw is happening right now. Our finalists are currently in New York competing. So wish them good luck in the Discord. Also, this past weekend, we did Buckeye CTF. Second place overall. Let's go. Clap. First place undergrad, which brings us to top 8 in the nation for CTFs, which is awesome. And if you competed and you did a write-up, that is due November 13th, and there'll be like $50 or $100 prizes for that. So you guys should definitely submit your write-ups. Yes, so flag for today is SIGPwny __ jailbreak. We'll talk about this __ syntax a little bit later. It's a special feature of Python. And I'll keep this up for a second so you guys can put in the flag. And the pony in the jail is like our hidden logo. No, it's never gets used, but we have like a second big logo. Yes. Okay, so what is a Python jail? So no, it's not an actual jail. You're not wearing handcuffs. Python jail is a restricted execution environment. So you may have heard of a sandbox before. A jail is similar to a sandbox, except that a jail operates in the same context as your program, and you have some sort of restriction placed on your input. Sandbox executes in a completely different environment, usually like an unprivileged context, and there's some sort of communication channel open to prevent vulnerabilities or you accessing files. So what does this look like? So a sandbox, right, will have our main program and like a separate sort of container for our sandbox. Our code will get sent to the sandbox. It'll get run. And in the sandbox, let's say we have no network access. We can't read or write to files. And once we've run their code, we just send the output of the program back to the main program. Alternatively, in a jail, we're running it in the same environment. So this can cause some problems, right? I have this little box with a lock on it. In the sandbox, there's no way to access the contents of the locked box. But in a jail, we can because it's in the same environment. So here is a very simple jail I have created. So basically what it does is it gets our user input, it executes user input, and then it's going to run our code. The code is expecting a function called add, and it's going to check if our function is correctly adding 2 numbers, right? So if we make it, if you define it like that, it will be incorrect. Define it like that, it'll be correct, right? But there's some problems with this, right? Let's say we give it the function import os.system, who am I, right? So the add function isn't defined, but when we run the program, it outputs username, right? It ran a command on our file system, even though we didn't want it to do that. It threw an error afterward. Obviously, name wasn't defined, but that's not the point. The point is that we were able to execute code on the computer. Right, so that's the output of who am I. So you may be wondering, this seems pretty niche. Why would anyone do this? If you guys have used LeetCode, HackerRank, your online assessment, or PrairieLearn, these are all some sort of execution environment, right? They're running user code. They don't know what it's going to do. It might be malicious. And sometimes people get lazy, right? They make a jail instead of a sandbox. Sandboxes are really hard to make correctly. They're complicated, right? It's hard to understand why this jail is insecure if you're not in cybersecurity. Jails are so simple, right? It's just the OS, or it's just the exec function. That's way simpler than running a whole virtual machine. So it's too complicated to make a sandbox. Okay, so now I'm going to talk about a couple types of jails in the context of CTF problems. So I like to call there like 3 different levels or like difficulties. So first one's be source limitation. So in our previous example, we ran this command os.system, who am I? So someone might think, okay, well, maybe let's just not let them use the word system in our program. Can we still execute any code we want? Yeah, of course. We can use any other different function. We could use process open. We could sort of split the string up, right? If it's just blacklisting the word system, we could split it into 2 different strings. We can use, what? I don't know how the pointer works. Oh, wow. Okay, yeah. So we could split up the string into 2 different parts, or we can use encodings, right? So this is hexadecimal encoding. The /x is the same input as this one, the import OS, but it's hexadecimal, so it gets past our blacklist of no system word. Oh, shit. Right, so if we execute rm-rf/, it's going to remove our whole file system. So we really need to be careful about these jails. So one more thing to note, sometimes they'll use eval instead of exec. So if we see our code is now using eval instead of exec, so we can't run more than one line of code at once. So it only accepts an expression. So the way we get around this is we can use like an import hook to make it all one line, right? Import OS, and in the same line, call who am I. We can also do this with accessing local and global variables, right? So if we know that they imported OS at the top of the file, we can access that with globals. Okay, so here is a mini challenge. I want you guys to try to solve it. So I've banned the words open, read, and a double quote. Does anyone have like a potential way we can read this file, flag/flag.txt, without using double quote, open, or read? Raise your hand if you do. Okay, it's fine. So this is some stuff that wouldn't work, right? We have process open that has the word open in it. We can't just read the file either that has the word read in there, and we can't use these double quotes. What we could do is, right, we could use system, and we could, instead of using double quotes, we can use single quotes. So yeah, that's one way to get around it. Yes, so cat, if you're not familiar, just outputs the contents of a file. So this is a shell command. Yeah, it'll just output the contents. Okay, so Python is hard, so I'm not going to go through this cheat sheet, but when you're doing the challenges, look at this. So Python is hard. They have this sort of concept. Everything is an object. So if you have like a int or a variable, you can pretty much access anything else in Python. So here is a giant info dump of everything. Yes, so quite a lot of things to go through. But sort of the point is that you can get from a variable to its class. You can get from a class to any other class, and you can get from a class to any function on that class. So, yep. Now I'll talk about environment jails. So the difference with an environment jail is we don't have any references to like variables. So if we check our global variables down here, we can see that like there's no import OS, there's no modules or anything. The only thing we have is like the print function and built-ins. So if we want to read the flag, we can access global built-ins, which is using this Python property. So this is in the cheat sheet as well. This is the access, yeah, built-ins. So it's equivalent to do built-ins Python thing as int, right? So they removed int, but they didn't remove built-ins, so we can still access the same stuff. Yes, and then a little bonus is we can actually break out just using the print function. So this is how this would work. So basically, we would go from print to the base class of print. So that should be just the object type in Python. We'll get every single subclass of that. And then we'll find a class we want to use, right? Maybe we want this built-in importer object. That sounds useful. If we look at the documentation for built-in importer, it says, oh, it just imports modules. That's great. So we just create the class and load OS system. Yeah. So sort of level 2 would be bytecode restrictions. So Python is a stack virtual machine. So you can technically remove like operations from the entire Python language. So last year at DICE, there was a cool challenge, and Nathan and who saw this? G. Sidica, who is that? Alex? Yeah, and Alex solved this last year. So I'll go through this super briefly. But bytecode restrictions are hard, right? It's hard to understand. Like this is sort of the assembly of Python. This is like Python bytecode, right? We can see these operations. It's like load a constant value. It's like compare a value, jump forward to a value. So this is the jail. I'll go through it super quick. So sort of the jail was, wow, this is really bad resolution. Holy shit. Damn. Maybe should have blown up the picture more. Okay. So sort of the restrictions were, there's no control flow. We can't use any double underscores, and we have a function that lets us set an attribute once. So if we check the documentation, they block all functions, but they don't block methods. Okay, that's interesting. We can use the GIF function to set its own code. There's this property on a function, underscore underscore code, that you can literally just take a function and change its code, which we can't quite do because we can't call functions, but that's useful to note. The other thing is we could, it doesn't like exit when we get a banned instruction, it just deletes the instruction. So it can sort of mess around with the stack to do stuff we're not supposed to, right? We can get a reference to a function, even though we're not supposed to make a function. And then we combine these together and, oh shit. Well, boom, we have the exploit. That's crazy. Wow. Okay, so looking for PrairieLearn. PrairieLearn uses Python jail. Can we pass any Python test case, right? I'd encourage everyone to look into PrairieLearn, be like, see if maybe it's insecure in some way, but maybe don't try it without asking them. They might get mad at you. Yes, try locally hosted instances. Yes, cool. A couple of resources. I'm gonna post one more slide show of like cheat sheet information, but this is a couple like exploit ideas. I know I went through like a lot of like pretty obscure like features. I think the best way is to sort of try out stuff on the cheat sheet and try out maybe exploits from this list and see what works. You can just use Google, and if you're solving challenges and you get stuck, just raise your hand and someone will be around to help you. Yes, and before I end, does anyone have any questions? Okay. Yes, anyone on Zoom? Okay, yes. Oh, sorry, Nora. This slide? The opcode? How far back? Wait, do you know which one? I think you might have been talking about the opcodes from the bytecode limitations. So, right, our Python is essentially turned into like assembly code, except it's called bytecode, Python stack language or whatever. So there's different like instructions, right? Instead of like move in assembly, there's like load constant. So in the PyJail from last year, they had, yeah, this picture's just like absolutely garbage, but like it says banned instructions are make function, call function, I don't know, KW and stuff. So these are banned instruction like opcodes, right? It's like similar to you can't use the move instruction, right? We can't use the make function instruction. But if we look at like the list of all sort of Python opcodes, and all the challenges today aren't going to use this sort of stuff. This is pretty crazy. But there's actually like a separate opcode for methods. That's different, right? So we can use the method opcodes instead of a function, because it's still like a method's like a function still. Yeah. Cool. Okay. All right. Next meetings. Yes. So this Sunday we'll have another one of Max's grad students presenting. It will be glyph positions, break PDF, text redaction. Don't know too much about it, but it should be cool. You guys should come. And then this Monday is the Origami Social I mentioned at the beginning. That'll be super good time. Hope to see everyone there. And then next Thursday, Min will be running forensics. So that'll be finding hidden information in file systems, images, and all other sorts of stuff. It'll be a good time. Yes. And that's it. Yes, go solve challenges. Can you put the cheat sheet slide up?
I was actually going to do
Oh.
and then we can switch it to just by the way, you can find Pete will upload the second cheat sheet that he has. But if you go to slides, you can find the current meeting slides and go to the slide with all the cheat sheet stuff in it.
I put this in.
Data structures. Yeah.
Blindly run code.
That's
Like, look, it works.
look at why. Yeah.
We'll waste it. Is this called Python jails?
Yes.
You could do like 0 and 0.5. I don't know how hard.
Yeah, 0.5 is quite simple as well.
Which one do you want to do?
0 and 0.5.
I'm assuming that 0 is
I think 0 has no restrictions. I don't know what the restriction on 0.5 is.
actually, I remember struggling with these. But that was because I was not paying attention.
It's okay.
This time I was paying attention. Yo,
Mhm.
bad now that I know Python.
Yeah, Python's just weird.
Okay.
So crazy. Yeah. Yeah. Okay, sorry about that, Zoom.
Zoom, can you hear us?
Yeah, so Zoom, we just ran through the first exploit, and now I'm going through an alternate way of solving the first challenge with the import hook instead of using multiple commands. So this underscore underscore import is exactly the same as running import OS on a new line. So we can do import OS, and now that we have the module OS, we can do system on this module. Right, so if we run ls, or I'll just cat. Right.
It timed out, but we're getting there.
Right, we get the same output out. Crazy. Should we do 0.5? Okay, and then I'll also do 0.5. So that's very similar. So let's take a look at this challenge. It's exactly the same, I think, maybe. No, it's not exactly the same. So we can see this time we're using this eval instead of exec. So if we look back at the slides, we remember that eval only lets us do one expression. So remember how this import hook, this is an expression, right? It's one line of Python code. But the import OS semicolon do something else is not an expression. That's like a whole Python program. So in this case, what we're going to want to do is, I don't know if we need to print it, but we'll use the import hook, and it says the word flag is banned. One way around this is we could split up the word flag into two parts, right? We could have a string like cat/fl and use the string concatenation plus to add it to the other part so it doesn't break our program. This prompt is quite long. You might need to print it. I'm not sure, but we'll see.
Oh, right, yeah.
You might need to print it. Okay, that works fine. Yeah. So Min is using the import hook, and then he's gonna import the module OS. And run system. We can't use the word flag directly, but he can use the string concatenation to add /fl to the remaining part, right? So now the word flag technically isn't our string, right? It's split up. So it should be fine, should pass the list. Yeah, we get the output. Yeah. Does anyone have any questions on this? Raise your hand if you do. The solution for the first one, yes. So the first one, you can use the same exact exploit, but you can scroll up to the multiple line one. The traditional way is, right, we're using import OS to get a reference to, Python's like call stuff, and then we'll do the command os.system on a separate line. One thing worth mentioning is Python actually also has a built-in way to read files without using OS. You want to show that? So this might not always work, but Python also, instead of just doing os.system cat, you can just do open the name of your file to read it out. Yeah. txt and then .read. Oh, you probably need to do print, yeah, because it's expression.
Right. We'll print it out.
So since this is an expression, we need to print it out. So he'll open up the file.
Oh, wow.
What? Exactly the same output. Yeah, so we can use this open instead of os.system to do the same thing, right? Open is equivalent to catting out the file with os.system. I've said os.system quite a lot.